What secret translation did Isaac Newton hide in his study? And why was he convinced that a cryptic Hermetic text held the keys to science itself? Picture this. It's 1680. The man who would become known as the father of modern physics sits hunched over his desk in Cambridge, not calculating the orbit of planets or the laws of motion, but carefully copying out an ancient alchemical text by candlelight. His quill scratches across parchment as he translates Latin phrases about transforming base metals into gold, about the marriage of opposites, about something called the one thing that supposedly underlies all of reality. This wasn't a hobby for Newton. This wasn't a curious side interest. By some estimates, Isaac Newton devoted more time to alchemy and the study of ancient Hermetic texts than he did to the physics that made him famous. And at the center of his obsession was a short, cryptic document that alchemists had treasured for over 1,000 years, the Emerald Tablet. Today, we think of Newton as the ultimate rational scientist, the man who gave us gravity, calculus, and the scientific method. But what if I told you that Newton himself believed his greatest discoveries came not from pure reason, but from decoding the secret wisdom of ancient Hermeticists? What if the very foundations of modern science grew out of medieval magic? The story of Newton's relationship with the Emerald Tablet isn't just about one brilliant man's unusual interests. It's about a moment in history when science and mysticism weren't opposites, but partners in the search for truth. And it raises a question that still haunts us today. Did Newton see something in that ancient text that we've forgotten? Was the greatest scientist of all time also the last great Hermeticist? The Newton you learned about in school is only half the man. Yes, he formulated the laws of motion, invented calculus, and discovered that white light contains all colors of the spectrum. But the Newton that history tried to hide spent decades pursuing what we'd now call occult studies. He wasn't just interested in how apples fall from trees. He wanted to understand the hidden forces that govern all transformation in the universe. When Newton arrived at Cambridge in 1661, the world of learning was still emerging from centuries of what we call the Renaissance, but what people then experienced as a rediscovery of ancient wisdom. Universities taught Aristotelian physics alongside courses on the natural magic of figures like Cornelius Agrippa. Students learned about the four elements: earth, air, fire, and water, not as primitive chemistry, but as fundamental principles that shaped both matter and consciousness. Into this world came a young Newton, hungry not just for mathematical certainty, but for a unified understanding of reality. He devoured the works of ancient philosophers, medieval alchemists, and Renaissance Magi. He read Plato's Timaeus for its cosmic geometry. He studied the alchemical writings attributed to Ramon Lull and the mysterious figure known as Basil Valentine. And he became fascinated by the Hermetic tradition, a body of philosophical and magical texts supposedly dating back to ancient Egypt. But did Newton spend more time on the Emerald Tablet than on gravity itself? The evidence is staggering. Among Newton's papers, preserved in the Cambridge University Library and other collections, are over 1 million words on alchemical subjects. That's more than 10 times the length of his famous Principia Mathematica, He filled notebook after notebook with alchemical experiments, copied out dozens of ancient texts by hand, and developed his own symbolic language for recording his investigations. Newton's alchemical laboratory was legendary even among his contemporaries. He built furnaces in his rooms at Trinity College and spent countless nights tending chemical processes that could take weeks or months to complete. His assistant, Humphrey Newton, no relation, later recalled how the great scientist would barely sleep during these operations, checking his furnaces at all hours, his eyes red from the smoke and the strain. What drove this obsession? Newton was searching for what alchemists called the prima materia, the first matter from which all things arise. He believed that if he could understand this fundamental principle, he could unlock the secrets not just of chemistry, but of physics, astronomy, theology, and even prophecy. For Newton, alchemy wasn't pseudoscience. It was the key to understanding God's design for the universe. The Emerald Tablet occupied a special place in this quest. This short text, supposedly written by Hermes Trismegistus, the legendary thrice great Hermes, was considered by alchemists to contain the ultimate secrets of transformation. Its cryptic phrases promise to reveal how the above and the below mirror each other, how all things have their birth from this one thing, and how the wise could learn to work with the fundamental forces of creation itself. Newton didn't just read the Emerald Tablet, he studied it like scripture. His personal copy, translated from Latin, is covered with marginal notes in his distinctive handwriting. He cross-referenced its phrases with other alchemical texts, tried to decode its symbolic language, and experimented with chemical processes that he believed the tablet described. Because for Newton, there was no contradiction between rigorous science and ancient wisdom. He believed that the ancients had possessed crucial knowledge that had been lost or corrupted over the centuries. His job, as he saw it, was to recover that wisdom and express it in the precise language of mathematics and natural philosophy. This wasn't unusual thinking for his time. Many of Newton's contemporaries, including Robert Boyle, the founder of modern chemistry, were also serious alchemical researchers. The idea that science and Hermeticism were fundamentally opposed is a modern invention. In Newton's era, studying the stars could lead you to astrology as easily as astronomy, and investigating the properties of matter naturally led to questions about the soul of the world. Newton's approach to alchemy was characteristically systematic. He read voraciously, collecting rare texts and comparing different versions of the same works. He developed elaborate classification systems for alchemical processes and symbols. He conducted hundreds of experiments, keeping detailed records in code to protect his discoveries from rivals. And always, he was looking for the mathematical principles that he believed governed alchemical transformations. What did Newton really mean when he wrote of the one thing? This phrase from the Emerald Tablet became central to his thinking. Newton believed that all the forces in nature, gravity, magnetism, chemical affinity, even life itself, were expressions of a single underlying principle. Just as white light contains all colors, this one thing contained all the specific forces and qualities we observe in the world. This wasn't just philosophical speculation for Newton. He genuinely believed he could discover the mathematical laws governing this fundamental principle. His famous inverse square law of gravitation was just one piece of a larger puzzle. Newton was convinced that the same mathematical relationships that governed planetary motion also governed chemical reactions, biological processes, and spiritual transformations. The Emerald Tablet seemed to confirm this vision. Its opening lines speak of how that which is below is like that which is above, and that which is above is like that which is below, to accomplish the miracles of the one thing. Newton read this as a statement of cosmic unity, the idea that the same principles operate at every scale of reality, from the smallest chemical reaction to the largest celestial movements. Modern historians have sometimes tried to separate Newton's real scientific work from his alchemical interests, as if they belonged to different phases of his career or different aspects of his personality. But Newton himself saw no such division. His investigation of gravity emerged from his alchemical belief in attractive and repulsive forces operating throughout nature. His work on optics was inspired by alchemical ideas about the relationship between light and matter. Even his mathematical methods reflected his conviction that the universe had a hidden, harmonious structure waiting to be decoded. The man who gave us the clockwork universe was actually pursuing something far more mysterious, a vision of reality where matter and spirit, physics and metaphysics, science and magic were different faces of the same underlying truth. And he believed the key to that truth lay hidden in the cryptic verses of an ancient Hermetic text. Newton's personal translation of the Emerald Tablet survives today, preserved among his papers in the Keynes collection at King's College, Cambridge. It's written in his careful, precise handwriting on a single sheet of paper. 13 lines that Newton believed contained the secret of secrets, the foundation of all natural philosophy. But this wasn't just any translation. Newton worked from multiple Latin versions of the text, comparing different manuscripts and weighing every word choice. He created what scholars now recognize as one of the most thoughtful and accurate English renderings of the Emerald Tablet ever produced. Every phrase was chosen with the precision he brought to his mathematical work. True it is, without falsehood, certain and most true, his translation begins. That which is below is like that which is above, and that which is above is like that which is below, to accomplish the miracles of the one thing. In Newton's margins, we can see his mind at work. Next to the phrase about the one thing, he writes cross-references to other alchemical texts. Where the tablet speaks of the sun as the father and the moon as the mother, Newton notes connections to his theories about active and passive principles in nature. Every cryptic line becomes a launching point for deeper investigation. Newton's translation reveals his systematic approach to decoding what he believed were natural laws expressed in symbolic language. Where many versions of the tablet are vague or contradictory, Newton's rendering is precise and consistent. He didn't see himself as inventing new knowledge, but as recovering truths that had been known to the ancients and then lost or obscured by centuries of ignorance. Newton believed that figures like Hermes, Trismegistus, Pythagoras, and Moses had possessed a complete understanding of natural philosophy that included what we now call physics, chemistry, astronomy, and even divine wisdom. This knowledge had been deliberately encoded in symbolic language to hide it from the unworthy. The job of the true philosopher, Newton's term for what we'd call a scientist, was to decode these ancient texts and express their insights in clear, mathematical terms. The Emerald Tablet represented the ultimate prize in this quest. According to alchemical tradition, it contained the complete secret of transformation, not just how to turn lead into gold, but how to understand and work with the fundamental forces that shape all change in nature. Newton read it as a kind of unified field theory, expressed in the symbolic language of Hermetic philosophy. His translation reveals his interpretive approach. Where many versions of the tablet are vague or contradictory, Newton's rendering is precise and consistent. He clearly understood the text as describing natural processes that could be studied experimentally. The tablet's references to generation and corruption, to the marriage of opposites, to the role of the sun and moon. Newton read all of this as encrypted descriptions of chemical and physical operations. Consider his rendering of the tablet's most famous passage. And as all things have been and arose from one by the mediation of one, so all things have their birth from this one thing by adaptation. Newton saw this as a statement about the fundamental unity of nature. All the diverse phenomena we observe, from falling apples to chemical reactions to the motion of planets, arise from a single underlying principle through various modifications and combinations. This wasn't abstract philosophy for Newton. He believed he could identify this one thing through experimental investigation. His alchemical notebooks are filled with attempts to isolate what he variously called the vegetable spirit, the magnetic virtue, or the active principle that he believed operated throughout nature. These weren't separate substances, but different manifestations of the same fundamental force. Newton's approach to the Emerald Tablet was characteristically systematic. He didn't just read it as a mystic seeking enlightenment, but as a natural philosopher seeking precise knowledge. He broke down each line, analyzed its relationship to other alchemical texts, and looked for experimental procedures that might embody its principles. His notes reveal particular fascination with the tablet's description of how its father is the sun, its mother the moon. Newton interpreted this as describing complementary principles that operate throughout nature, active and passive, hot and cold, expanding and contracting forces that together drive all natural processes. This wasn't just chemical symbolism for Newton. He saw it as describing real forces that he could study and quantify. Could modern science have grown out of Hermetic magic? Newton's approach to the Emerald Tablet suggests the answer might be yes. His translation shows him treating the text as a condensed summary of natural laws, encoded in symbolic language, but describing real, observable phenomena. The same mind that would later discover the mathematical laws of motion and gravitation was here trying to decode what he believed were even more fundamental principles governing all transformation in nature. What's remarkable about Newton's translation is how it bridges two different ways of understanding reality. The language is still that of traditional alchemy, references to the green lion, the philosophical Mercury, the marriage of opposites. But Newton's marginal notes and cross-references show him translating these symbols into the mechanical and mathematical terms that would characterize modern science. For example, where the tablet speaks of how the wind carries it in its belly, Newton notes connections to his theories about the subtle spirit that he believed permeated all matter. This wasn't supernatural thinking, but an early version of what we might now call field theory. The idea that forces operate through some kind of medium or substrate. Newton's experimental notebooks from this period show him trying to identify and isolate this subtle spirit through chemical operations. He conducted hundreds of experiments, varying temperatures, timing, and materials in systematic ways that prefigure modern experimental methodology. The difference was that he was looking not just for new compounds or reactions, but for evidence of the fundamental principles described in texts like the Emerald Tablet. His translation work also reveals Newton's conviction that ancient wisdom and modern discovery should ultimately converge. He believed that if he could correctly decode the Emerald Tablet's symbolic language, he would find it describing the same natural laws that his mathematical physics was revealing through observation and calculation. This convergence wasn't just theoretical for Newton. Consider his law of universal gravitation, the mathematical breakthrough that revolutionized astronomy. In his private notebook De Gravitatione, Newton explicitly connects gravitational attraction to alchemical principles about sympathies and antipathies operating throughout nature. Where the Emerald Tablet speaks of how that which is below is like that which is above, Newton saw a statement about forces operating consistently across all scales of reality. His famous apple and moon insight didn't emerge from pure mathematical reasoning alone. It grew from his alchemical conviction that the same attractive principles governing chemical reactions, what alchemists called magnetic virtue, must also govern celestial motions. The mathematical formulation was revolutionary, but the underlying insight about universal attractive forces came directly from his study of Hermetic texts. What if Newton saw the Emerald Tablet as scripture or experiment? His translation suggests he saw it as both. The text carried the authority of ancient wisdom, but it also described natural processes that could be investigated experimentally. Newton's genius lay in his ability to hold both approaches simultaneously, respecting the traditional authority of the text while subjecting its claims to rigorous experimental testing. This dual approach is visible throughout Newton's translation. He preserves the tablet's mysterious, oracular tone while adding notes that reveal his efforts to translate its symbols into precise, testable propositions. The result is a document that stands at the intersection of two worlds: the world of traditional Hermetic wisdom and the world of mathematical natural philosophy that Newton was helping to create. Newton's translation of the Emerald Tablet thus represents more than just one man's curious hobby. It's a window into a crucial moment in the history of human thought, the moment when ancient wisdom traditions began to transform into modern science, not by rejecting the old, but by subjecting it to new methods of investigation and verification. Newton's study of the emerald tablet wasn't separate from his revolutionary work in physics and mathematics. It was central to it. For Newton, the tablet provided the philosophical foundation for a unified understanding of nature that could encompass everything from planetary motion to chemical reactions to the structure of space and time itself. The key insight Newton drew from Hermetic philosophy was the principle of unity in diversity. The Emerald Tablet's famous declaration that, as above, so below, wasn't just mystical poetry to Newton. It was a statement of scientific method. If the same laws operate at every scale of reality, then studying earthly phenomena could reveal the principles governing celestial motions, and understanding the motion of planets could illuminate the forces operating in chemical reactions. This Hermetic principle of correspondence became fundamental to Newton's approach to natural philosophy. His law of universal gravitation exemplifies this thinking. Newton proposed that the same force that causes an apple to fall from a tree also keeps the moon in orbit around Earth and holds the planets in their courses around the sun. This wasn't obvious to his contemporaries. Many found it absurd to suggest that earthly and celestial phenomena obeyed the same laws. But Newton's conviction came partly from his study of Hermetic texts like the Emerald Tablet, which taught that the universe has a fundamental unity beneath its apparent diversity. What appeared to be different phenomena, terrestrial gravity, planetary motion, tidal forces, were actually manifestations of a single underlying principle operating according to consistent mathematical laws. Newton's search for unity went beyond gravity. His work on optics revealed that white light contains all colors of the visible spectrum. Again, unity underlying apparent diversity. His development of calculus provided a mathematical language for describing continuous change and transformation, core concepts in alchemical thought. Even his laws of motion can be seen as attempts to identify the fundamental principles governing all change and transformation in the physical world. What did Newton really mean when he wrote of the one thing? His private papers reveal that he interpreted this central concept from the Emerald Tablet as referring to what we might now call a unified field, a single fundamental principle that manifests as all the various forces and phenomena we observe in nature. Newton believed this one thing was simultaneously physical and spiritual, material and mental. It was the source of gravity, magnetism, chemical affinity, and life itself. It operated according to mathematical laws that could be discovered through careful observation and experiment, but it also had qualities that traditional matter in motion physics couldn't fully capture. This search for the one thing drove much of Newton's experimental work. His alchemical laboratory wasn't separate from his physics research. It was where he tried to isolate and study the fundamental principle that he believed underlay all natural phenomena. His experiments with metals, acids, and various chemical processes were attempts to observe the one thing in operation, to understand how it manifested as specific forces and qualities. Newton's approach to this investigation was characteristically systematic. He developed elaborate classification systems for different types of chemical operations, correlated them with astronomical events, and looked for mathematical relationships that might govern the transformations he observed. This wasn't primitive chemistry. It was an early form of what we might call systems theory, an attempt to understand how complex phenomena emerge from simpler underlying principles. The Emerald Tablet provided Newton with a theoretical framework for this investigation. Its description of how all things have their birth from this one thing by adaptation suggested to Newton that the diversity of nature emerges through various modifications and combinations of a single fundamental substance or principle. This wasn't unlike modern physics' search for a theory of everything that could explain all fundamental forces and particles in terms of more basic principles. Could physics itself be Hermetic wisdom in disguise? There are striking parallels between Newton's mature physics and traditional Hermetic philosophy. Both emphasize the fundamental unity of nature beneath apparent diversity. Both propose that the same principles operate at every scale of reality. Both suggest that understanding these principles gives humans a kind of creative power over natural processes. Newton's concept of absolute space and time, which provided the framework for classical physics, shows clear influence from Hermetic ideas about the spirit of the world, an invisible medium that permeates all things and provides the context for physical interactions. His conviction that mathematical laws govern natural phenomena reflects the Hermetic belief in cosmic harmony and order. Even Newton's method, combining mathematical analysis with experimental investigation, has Hermetic precedence. Traditional alchemists combined theoretical study of ancient texts with practical laboratory work, believing that both approaches were necessary to understand natural processes. Newton's innovation was to express the insights gained through this combined approach in the precise language of mathematics. The influence worked both ways. Newton's mathematical successes seemed to confirm Hermetic claims about the fundamental rationality and harmony of nature. If the motion of planets could be predicted using simple mathematical formulas, if the behavior of light could be analyzed using geometric principles, then perhaps the ancient sages were right to claim that the universe has an underlying mathematical structure. This convergence of Hermetic philosophy and mathematical physics wasn't accidental. Newton consciously drew on both traditions in developing his understanding of nature. His private correspondence reveals that he saw his mathematical discoveries as confirmations of insights that had been preserved in ancient wisdom traditions, but expressed in symbolic rather than mathematical language. For Newton, the Emerald Tablet was like a compressed file containing the complete program of natural philosophy. His job was to unpack that file, to translate its symbolic language into mathematical formulas and experimental procedures. The tablet's cryptic references to the sun and moon, to the marriage of opposites, to the generation and corruption of substances. Newton read all of this as encoded descriptions of the natural laws that his physics was making explicit. This approach helped Newton avoid some of the limitations of purely mechanical thinking. While his contemporaries often tried to explain all phenomena in terms of matter and motion, Newton's Hermetic background made him open to forces and principles that couldn't be reduced to mechanical collisions. Gravity, magnetism, and chemical affinity all seemed to involve action at a distance, influences that operated without direct physical contact. Traditional mechanical philosophy had difficulty explaining such phenomena, but Hermetic theory had always emphasized invisible forces and sympathies operating throughout nature. Newton's achievement was to show that these forces, while invisible, still operated according to precise mathematical laws that could be discovered and verified experimentally. What if the Emerald Tablet shaped modern science without anyone realizing it? The evidence suggests this might be exactly what happened. Newton's physics, which provided the foundation for the scientific revolution and the modern worldview, was deeply influenced by his study of Hermetic texts like the Emerald Tablet. But this concealment was so successful that most people today still think of Newton as purely rational. It wasn't until the 20th century, when economic pressures forced Newton's descendants to sell his private papers, that the full extent of his Hermetic investigations became clear. The irony is that Newton's Hermetic approach may have been what made his scientific breakthroughs possible. His willingness to see unity beneath diversity, his conviction that mathematical laws govern natural phenomena, his openness to invisible forces and action at a distance. All of these insights, which proved crucial to the development of modern physics, can be traced back to his study of texts like the Emerald Tablet. Modern science thus carries within itself, often without recognizing it, insights that originated in Hermetic philosophy. The search for unified field theories, the conviction that the same laws operate throughout the universe, the belief that mathematical analysis can reveal the deepest truths about reality. All of these characteristic features of scientific thinking have roots in the tradition that Newton encountered when he first translated the Emerald Tablet in his Cambridge study. For over 2 centuries after Newton's death in 1727, his alchemical papers remained hidden from public view. His family, executors, and the scientific establishment that revered his memory seemed to agree on one thing: Newton the alchemist was an embarrassment to Newton the scientist. These manuscripts, containing over 1 million words on alchemy, Hermetic philosophy, and apocalyptic prophecy, were locked away, dismissed as the unfortunate delusions of an otherwise brilliant mind. Why were his alchemical notebooks locked away for centuries? The answer reveals as much about the changing nature of science as it does about Newton himself. By the 18th century, the scientific community was actively defining itself in opposition to what it saw as superstition, mysticism, and occult thinking. The Enlightenment valorized reason, experiment, and mathematical analysis, while rejecting anything that smacked of medieval magic or Hermetic wisdom. Newton's heirs understood this cultural shift. When they organized his papers after his death, they carefully separated his scientific work, the mathematics, physics, and astronomy, from his unscientific interests in alchemy and prophecy. The respectable papers were donated to Cambridge University and other institutions. The embarrassing ones were stored in family estates, effectively removed from scholarly circulation. This concealment wasn't just about protecting Newton's reputation. It reflected a broader transformation in how Western culture understood the relationship between science and other forms of knowledge. The medieval world that Newton had grown up in still saw natural philosophy, theology, and Hermetic wisdom as complementary approaches to understanding reality. But by the late 18th century, these domains were increasingly seen as incompatible. The scientific revolution that Newton had helped launch was now being interpreted as a victory of reason over superstition, of empirical investigation over ancient authority. From this perspective, Newton's interest in texts like the Emerald Tablet could only be seen as a regrettable lapse, a remnant of pre-scientific thinking that had somehow survived in the mind of the first modern scientist. But this sanitized version of Newton couldn't last forever. In 1936, these manuscripts came up for auction at Sotheby's in London. The scientific establishment showed little interest. They were still embarrassed by their contents. Most of the alchemical papers were purchased by private collectors, including the economist John Maynard Keynes. When Keynes examined what he'd bought, he was astonished. In a famous essay, he declared that Newton was not the first of the age of reason. He was the last of the magicians. Here was evidence of a Newton who had devoted more time to alchemy than to physics, who believed ancient sages had possessed crucial knowledge about reality's deepest principles. This discovery revolutionized our understanding of the scientific revolution itself. Scholars realized that the traditional story, rational investigation gradually replacing superstition, was far too simple. The actual history involved continued interaction between different traditions of knowledge rather than simple replacement. Newton's alchemical investigations weren't primitive fumbling, but sophisticated, systematic research guided by theoretical principles. His experimental notebooks reveal recognizably scientific methodology, controlled experiments, careful observation, theoretical interpretation. The difference was that he sought not just new compounds, but evidence of the fundamental principles described in texts like the Emerald Tablet. More surprisingly, many of Newton's most famous scientific insights can be traced back to his alchemical studies. His concept of gravitational force, his understanding of chemical processes, even his mathematical methods, all show influence from Hermetic principles about the unity and interconnectedness of nature. The rediscovery of Newton's secret work has also influenced broader cultural developments. The 20th century saw renewed interest in Hermetic philosophy, alchemy, and other esoteric traditions that had been dismissed during the Enlightenment. Figures like Carl Jung drew on alchemical symbolism in developing analytical psychology. Alternative spiritual movements like theosophy and anthroposophy claimed descent from the same Hermetic tradition that had influenced Newton. Could physics itself be Hermetic wisdom in disguise? Some modern thinkers have suggested that developments in 20th century physics, quantum mechanics, relativity theory, field theory, represent a return to essentially Hermetic ways of thinking about reality. The emphasis on fundamental unity, the recognition that observer and observed are interconnected, the search for underlying principles that manifest as diverse phenomena. All of these themes echo traditional Hermetic philosophy. This doesn't mean that modern physics is simply ancient wisdom in new dress. The mathematical precision and experimental rigor of contemporary science represent genuine advances over traditional Hermetic thinking. But it does suggest that the relationship between scientific and mystical approaches to reality may be more complex than the standard Enlightenment narrative suggests. Newton's translation of the Emerald Tablet stands at the center of these questions. Here is the founder of mathematical physics, the man who gave us the clockwork universe, carefully studying a cryptic, Hermetic text and finding in it the philosophical foundation for his scientific worldview. The image challenges our assumptions about both the nature of scientific thinking and the value of traditional wisdom. What's particularly striking is how Newton's approach to the Emerald Tablet prefigures some characteristic features of modern scientific method. His careful comparison of different versions of the text resembles the modern practice of peer review and reproducibility. His systematic attempts to decode the tablet's symbolic language parallel contemporary efforts to develop mathematical models of natural phenomena. His integration of theoretical study with experimental investigation became the standard approach of modern science. But Newton also brought to his study of the Emerald Tablet something that purely rational approaches often miss: a sense of wonder, a conviction that reality has depths that pure mechanism cannot capture, an openness to possibilities that transcend conventional thinking. These qualities, which he derived from his study of Hermetic texts, may have been essential to his ability to make revolutionary discoveries about the nature of space, time, and matter. The legacy of Newton's secret work thus poses ongoing questions about the nature and limits of scientific knowledge. If the founder of mathematical physics was also a serious student of Hermetic wisdom, what does that tell us about the relationship between rational investigation and other ways of knowing? Can we afford to dismiss traditional wisdom as mere superstition? Or might it contain insights that complement and enrich scientific understanding? These questions have become increasingly relevant as contemporary science encounters its own limits and paradoxes. Quantum mechanics suggests that reality at its most fundamental level may be far stranger than classical physics imagined. Environmental crisis raises questions about whether purely technological approaches to nature are sufficient. The hard problem of consciousness continues to resist reduction to purely physical terms. In this context, Newton's example suggests that the most productive approach may not be to choose between scientific and mystical ways of knowing, but to find ways of integrating them that preserve the strengths of both. His translation of the Emerald Tablet represents one historical example of such integration, a moment when ancient wisdom and mathematical precision worked together to reveal new truths about the nature of reality. Standing in his study in the early hours of a Cambridge morning, surrounded by furnaces still warm from the night's experiments, Newton faced a question that haunts us still. Are there truths about reality that pure reason alone cannot reach? His translation of the Emerald Tablet, with its cryptic promises of hidden knowledge and universal principles, suggested there might be. Was he wrong, or simply ahead of his time? 3 centuries later, we're still grappling with the same fundamental questions that drove Newton to spend his nights copying ancient alchemical texts by candlelight. Modern physics has revealed a universe far stranger than the clockwork cosmos that Newton's public reputation helped create. Quantum mechanics suggests that reality at its deepest level operates according to principles that seem to transcend ordinary logic. Relativity theory reveals that space and time are not fixed containers, but dynamic aspects of a unified space-time continuum. These discoveries would not have surprised the Newton who translated the Emerald Tablet. His private papers reveal a thinker who always suspected that the mechanical philosophy of his era, the idea that everything could be explained in terms of matter and motion, was inadequate to capture the full complexity of nature. His Hermetic studies convinced him that reality has qualities and dimensions that purely mathematical description cannot encompass. The Emerald Tablet's central teaching about the one thing, from which all diversity emerges, resonates strikingly with contemporary physics' search for a theory of everything that could unify all fundamental forces. Newton's conviction that, as above, so below, that the same principles operate at every scale of reality, anticipates modern insights about the fundamental unity of the cosmos, from quantum mechanics to general relativity. But Newton's approach to the Emerald Tablet also suggests something that modern science has perhaps lost: a sense that understanding nature requires more than just mathematical analysis and experimental manipulation. The tablet's language of transformation, of the marriage of opposites, of the role of time and patience in natural processes, all of this points toward a more organic, more participatory relationship between knower and known. Was the greatest scientist of all time also the last great Hermeticist? The evidence suggests that Newton managed to be both simultaneously, and that this dual identity was not a contradiction, but a source of creative tension that fueled his most important discoveries. Newton's mature physics preserves essential insights from Hermetic philosophy while subjecting them to rigorous mathematical and experimental testing. His law of universal gravitation embodies the Hermetic principle of cosmic unity while expressing it in precise mathematical language. His understanding of space and time as absolute frameworks reflects traditional ideas about the spirit of the world that permeates all things, but translates these concepts into the geometric language of mathematical physics. What if the Emerald Tablet shaped modern science without anyone realizing it? The historical evidence suggests this is exactly what happened. Newton's physics, which provided the foundation for the scientific worldview that still dominates Western culture, was profoundly influenced by his study of Hermetic texts. But this influence was so successfully concealed that for centuries scholars barely acknowledged Newton's alchemical interests. This concealment had profound consequences. By presenting Newton as a purely rational scientist who rejected ancient wisdom in favor of mathematical analysis, the scientific establishment created a false opposition between reason and tradition, between empirical investigation and symbolic thinking. This opposition has impoverished both scientific and spiritual understanding, creating unnecessary conflicts between different ways of knowing. Newton's actual approach was far more sophisticated. His translation of the Emerald Tablet reveals a mind capable of holding multiple perspectives simultaneously, respecting the authority of ancient wisdom while subjecting its claims to rigorous experimental testing, preserving traditional symbolic language while translating its insights into mathematical formulations. This integrative approach may be exactly what we need today. contemporary science faces challenges that purely reductionist thinking seems unable to address. Climate change requires understanding complex, interconnected systems where small changes can have large, unpredictable effects. Consciousness research encounters phenomena that resist reduction to purely physical terms. Even fundamental physics suggests that reality may be far more mysterious and interconnected than classical materialism assumed. Did Newton see something in that ancient text that we've forgotten? His careful study of the Emerald Tablet suggests he found there a vision of reality as fundamentally alive, interconnected, and purposeful, qualities that purely mechanical thinking tends to miss or dismiss. The tablet's emphasis on transformation and development resonates with contemporary insights from evolutionary biology, complexity theory, and ecological thinking. Its recognition that understanding requires both knowledge and wisdom, both analysis and synthesis, anticipates holistic approaches that are becoming increasingly important in fields from systems biology to environmental science. Newton's approach to the Emerald Tablet also prefigures contemporary discussions about the role of consciousness in physical processes. The tablet's language suggests that understanding nature requires a kind of participatory knowing. The observer must somehow align with or attune to the processes being studied. This idea, which seemed like primitive mysticism to 19th century scientists, now appears remarkably prescient given quantum mechanics insights about the role of measurement in determining physical outcomes. What did Newton see when he looked at those 13 cryptic lines? His marginal notes suggest he saw a compressed summary of natural laws that his mathematical physics was just beginning to unpack. The tablet's references to the sun and moon, to generation and corruption, to the marriage of opposites. Newton read all of this as symbolic descriptions of forces and processes that could be studied experimentally and expressed mathematically. But he also saw something more. The Emerald Tablet promised not just knowledge about nature, but wisdom about humanity's place within the cosmic order. It suggested that understanding the principles governing physical transformation could also illuminate the processes of spiritual development. For Newton, studying alchemy and physics were aspects of a single quest to understand what he called the frame of the world, the underlying structure that gives order and meaning to reality. This vision of integrated understanding, where scientific investigation and spiritual development mutually inform each other, was central to Newton's mature worldview. His public writings on physics and mathematics were just one aspect of a larger project aimed at recovering and expressing the fundamental principles that govern both natural and human existence. The tragedy is that this integrated vision was lost as Newton's successors developed his mathematical methods while abandoning his philosophical framework. The clockwork universe of 18th century physics preserved Newton's mathematical insights, but lost his sense of the cosmos as a living, purposeful whole. Science became increasingly specialized and reductionist, losing touch with the broader questions about meaning and value that had originally motivated figures like Newton. Could Newton's hidden passion change how we see science itself? The rediscovery of his alchemical papers in the 20th century has already begun to transform our understanding of the scientific revolution and the nature of scientific thinking. We now know that the opposition between science and mysticism that seemed so obvious to later centuries was largely a retrospective construction. But the implications go deeper than historical revision. Newton's example suggests that the most creative scientific thinking may occur at the boundaries between different ways of knowing, where rigorous analysis meets intuitive insight, where mathematical precision encounters symbolic wisdom, where experimental investigation opens onto broader questions about the nature of reality and our place within it. Contemporary developments in science seem to be rediscovering some of these boundary regions. Quantum mechanics reveals aspects of reality that classical physics couldn't capture. Chaos theory and complexity, science study phenomena that emerge from the interaction of simple rules but cannot be predicted from them. Ecological thinking emphasizes interconnection and interdependence over simple cause and effect relationships. These developments don't validate every claim made by traditional wisdom traditions any more than Newton's physics validated every statement in alchemical texts. But they do suggest that reality is complex and mysterious enough to require multiple approaches and perspectives for adequate understanding. What if Newton's translation of the Emerald Tablet points toward a new synthesis, not a return to pre-scientific thinking, but an integration that preserves the precision and rigor of modern science while recovering some of the wisdom and breadth of traditional philosophy? Such a synthesis might recognize that mathematical analysis and experimental investigation, while extraordinarily powerful, are not the only valid ways of engaging with reality. Intuitive insight, symbolic thinking, contemplative practice, and ethical reflection might all have roles to play in developing comprehensive understanding. Newton's approach to the Emerald Tablet suggests what such integration might look like. He brought the full rigor of his mathematical and experimental training to bear on traditional texts. But he also remained open to insights that couldn't be captured in purely quantitative terms. He translated symbolic language into mathematical formulas, but he also preserved his sense that the symbols pointed toward truths that the formulas could express but not exhaust. This kind of integrative thinking is becoming increasingly important as we face challenges that require both scientific precision and wisdom about values, meaning, and purpose. Climate change, artificial intelligence, biotechnology, and other contemporary issues cannot be adequately addressed through purely technical approaches. They require understanding not just how natural and technological systems work, but how they relate to human flourishing and the broader web of life. Newton's study of the Emerald Tablet reminds us that such integration is possible. The man who gave us mathematical physics was also a serious student of ancient wisdom, and he found in that study not a distraction from scientific work, but a foundation for it. His translation of the tablet stands as a testament to the possibility of rigorous thinking that is also open to mystery, of precise analysis that serves broader understanding. The eternal question that Newton faced in his Cambridge study, whether there are truths about reality that pure reason alone cannot reach, remains as relevant today as it was 3 centuries ago. His example suggests that the answer is yes, but that acknowledging this doesn't require abandoning rational investigation. Instead, it means embedding such investigation within a larger framework that recognizes the complexity and depth of reality. As we stand at our own threshold between old and new ways of understanding, Newton's translation of the Emerald Tablet offers both inspiration and guidance. It shows us what becomes possible when brilliant minds remain open to wisdom from unexpected sources, when rigorous analysis serves the quest for comprehensive understanding, and when the search for truth encompasses both the mathematical laws governing matter and motion and the deeper principles that give meaning and direction to existence itself. In the end, Newton's greatest discovery may not have been the law of universal gravitation or the mathematical principles of natural philosophy, but rather a way of thinking that could hold both ancient wisdom and modern science in creative tension. His translation of the Emerald Tablet stands as a monument to this achievement, 13 cryptic lines that helped launch the scientific revolution while preserving insights that purely mechanistic thinking might have lost. The question remains, what would our science look like if it fully embraced this Newtonian integration? What discoveries await us if we can learn to combine the precision of mathematical analysis with the wisdom of a traditional philosophy, the rigor of experimental method with the depth of contemplative insights? Newton's translation of the Emerald Tablet cannot give us final answers to these questions, but it can point us toward the kind of thinking that might find them. In its careful balance of respect for ancient wisdom and openness to new discovery, in its integration of symbolic insight and mathematical precision, in its conviction that understanding nature requires both rigorous analysis and patient attunement to deeper patterns and purposes. In all of this, Newton's approach to the Emerald Tablet offers a model for the kind of science we might need in the centuries ahead. The tablet promises that those who understand its teaching will possess the glory of the whole universe, and all darkness will flee from them. Newton spent his life trying to fulfill that promise, and in doing so, he gave us both modern science and a vision of how that science might serve not just technological power, but wisdom, understanding, and the flourishing of life itself. In his translation of 13 ancient lines, Newton encoded a revolution that is still unfolding. Whether we have the wisdom to complete what he began remains the eternal question that each generation must answer for itself.